Welcome to today's Explainer. We're looking at a question that literally pushes the absolute limits of human comprehension. What lies beyond the observable universe? Today, we are taking a structured journey right to the very edge of reality, using our source material to guide us. So, let's break it down. Okay, let's dive into this. What exactly lies beyond the observable universe? In cosmology, we spend a massive amount of resources mapping out the cosmic web, tracking galactic superclusters, and measuring the cosmic microwave background radiation. But the research we're unpacking today challenges us to step mathematically and conceptually past those physical boundaries. We're moving beyond the 46.5 billion light-year radius of the observable universe to ask what happens when the very fabric of space-time extends further than our cosmological horizon.
Section 1. The Observable Universe. Our starting point. To understand what's beyond, we have to understand where we are right now.
The observable universe is defined as the specific, limited portion of the entire cosmos that can currently be seen or comprehended from our vantage point. And the crucial limitation here is the speed of light combined with the age of the universe. Because the universe is about 13.8 billion years old, light from objects further away than that simply hasn't had enough time to reach our telescopes yet. When you factor in the expansion of space itself, cosmologists calculate the radius of our observable bubble to be roughly 46.5 billion light-years in any direction. This creates a hard spherical boundary, a cosmic horizon. Not because space ends there, but because information is fundamentally constrained by causality and the speed of light. We are permanently isolated within this sphere of comprehension. Now, you might be thinking, a boundary implies an edge, right? Well, in astrophysics, this isn't some physical drop-off or a structural wall. It's a cosmological horizon. Beyond this horizon, galaxies are actually receding from us faster than the speed of light due to the expansion of space, making them forever causally disconnected from us. So when we talk about this edge, we're really talking about an absolute limit of empirical observation. Yet, the principles of cosmological isotropy, which is basically the idea that the universe looks the same in all directions, strongly suggest that the topological conditions of our universe don't just suddenly change the moment you cross that horizon. The laws of physics continue, meaning this edge isn't a termination of space, but rather a frontier of our perceptual limits.
Let's move to Section 2 and see how this builds. The infinite edge, approaching the limits of space.
When we start comparing realities, we encounter a massive shift in scale. We have the observable universe, which is known and firmly bounded by the speed of light. Contrast that with the infinite edge of space, a concept that is entirely unknown and boundless. Reconciling these two realities is honestly one of the most compelling challenges in theoretical physics. The theory of cosmic inflation posits that in the very first fraction of a second after the Big Bang, space expanded exponentially. While our observable bubble stopped inflating and became a stable pocket, the broader space-time fabric may have just continued expanding infinitely. It elegantly explains how a strictly bounded and measurable observable universe can exist perfectly embedded within an infinitely sprawling, unobservable reality. Now, exploring the infinite edge of space presents a really fascinating paradox. How can an edge be infinite? Well, current measurements of the cosmic microwave background suggest that the geometric curvature of the universe is extremely close to flat. And in cosmology, a perfectly flat universe mathematically implies an infinite spatial extent. Therefore, the edge isn't a geometric boundary at all, but a moving horizon within an endless continuum. This means the edge of space is an infinite volume itself. For literally every light year you travel past our cosmic horizon, you simply find more space, more galaxies, and more of the universe's uniform distribution of matter continuing endlessly. Section 3. Multiverse Theories. Breaking Through the Barrier. We are now zooming completely out of our own universe to explore the theories of what might lie beyond that infinite edge. The implications of multiverse theories absolutely stretch our understanding of reality. Let's break this down. First, there's existence beyond the observable edge. This is supported by eternal inflation theory, which suggests that quantum fluctuations in the early universe caused certain regions of space to stop inflating, while the rest kept going, creating separate bubble universes. Second, the reality of infinite space means these inflationary bubbles are continually forming in an endlessly expanding medium. And third, the possibility of multiple universes introduces mind-bending concepts like the many worlds interpretation of quantum mechanics, where every single quantum event branches into a new, distinct reality. Whether derived from string theory, landscapes, or eternal inflation, the physics strongly implies that our universe is far from unique. So, The crucial point is that we are moving from one universe to many. It is a massive, fundamental paradigm shift in human understanding. To put this in perspective, physicists have pointed out that in an infinite spatial expanse, there are only a finite number of ways matter can arrange itself quantum mechanically. Eventually, if you travel far enough through this infinite space, particle arrangements are forced to repeat. This means somewhere out there in the sprawling multiverse, there is highly likely an exact duplicate of our observable universe, right down to the atomic level, simply because infinity guarantees all statistical probabilities are exhausted and eventually repeated. Our supposedly unique reality might just be a highly localized, repeating phenomenon.
Which leaves us with this. If our observable universe is just one of many within an infinite space, what else is out there waiting to be discovered? It's a question that completely redefines our place in the cosmos. By moving from our known boundaries to the mathematical probability of spatial infinity, and finally into the mechanics of the multiverse, we realize that our journey of discovery is truly just beginning. Thank you for joining me for this explainer today, and keep questioning those limitless mysteries of the multiverse.